All right, let me know when to go ahead and get started.
Yeah, sure. Please start.
Okay, very good. Well, good afternoon, everyone. Good evening from Bangladesh. Good morning from the US. My name is Sam
Morning.
Nasr. I'm sorry.
I said good morning.
Ah, good morning. So my name is Sam Nasr, and this session is using existing data to create a machine learning application. A little bit about me. You can find me on Twitter at Sam Nasr. I have been a software developer since 1995, and I'm currently the senior software engineer for NIS Technologies. I've been certified with a few certifications from Microsoft, and one of my biggest prides and joys is running the Cleveland C# VB.NET user group, as well as the .NET study group. In addition, I've authored several articles for Visual Studio Magazine, and I've been a 5-time Microsoft MVP. In addition to those activities, one of the other things that I loved is to run the Azure Cleveland user group. So chances are, if you're attending this session, you'd have some interest in Azure. We meet every second Wednesday. The meetings are free of charge and open to the public, and we cover a variety of topics related to Azure, such as infrastructure as a service, platform as a service, and of course, software as a service. You can find the meeting information posted on meetup.com at the link listed below. So let's get right into it. As far as machine learning, what we're doing is we're essentially using machine learning to develop a model that will allow us to be able to integrate machine learning into the .NET application, and it's applicable to .NET or .NET Core. We can use this in an online or offline scenario, and it uses patterns to make data predictions versus explicit logic, meaning we give it the data, it develops the formula, if you will, or the calculations to be able to predict based on a set of data that we give it or features, and it's able to predict what the outcome will be. So some of the things that we'll discuss are, for example, housing prices. So in the United States, one of the big factors is square footage. But obviously there's other factors that influence the price of a home, such as location, as well as other amenities that are in the home. So we give it all these features that would pertain to the price, and then we give it the final price, and then we give it essentially a lot of records that it's able to learn from and then develop the formula from that. So that's what we're referring to when we talk about a machine learning model. It's essentially the logic, once we give it the data, that it develops as far as being able to give an output result given a certain set of data criteria. So the ML.NET or machine learning.NET model, it's basically an object that we're going to incorporate within our application, and it contains what are called the transformations. So like I said earlier, with machine learning, we give it the data and what the expected output result will be, and it essentially develops a formula of what is used to take the input and produce the output. And so basically that formula that it comes up with is referred to as a transformation. So one of the things that we can pick up are essentially linear regression. So there are some things that are proportional. So like we mentioned, the square footage of a home in comparison to the price, we see that it is directly proportional to it, as opposed to other things, for example, such as the HDL cholesterol versus the BMI, that is inversely proportional. So as my BMI rises, so does my good cholesterol drops. And so that is an inverse proportion type of relationship. So once we give the machine learning model adequate data, it is able to develop the transformation to be able to devise a formula for the output. And in many cases, it's linear, similar to what we had seen here. So in order to get a better understanding of how things work, first we need to cover the terminology. So a feature is basically the input for the machine learning model. Like we talked about the square footage of the home, the size. If we're dealing with cars, then it would be the mileage. The higher the mileage, the lower the price. So that's an inverse proportional relationship. With a home, again, as the size of the home increases, so does the price. So a feature is what we're giving into the model. The label, that's essentially the value or the output value that will be produced and that is what the ML model is used to train on. And then what happens in between is that transform, meaning the type of prediction that is used to identify the output results. So I refer to it as a formula, but it's really much more than that. So the different types of prediction types that we have, and again, it's readily available all behind the scenes, but we can select and choose which type of prediction that we want to develop. So we can do things like classification, where we're essentially taking one item and then defining it into one category, such as if it's an edible item, is it a fruit, is it a vegetable? We can do regression, as we had seen earlier, with the price of the home or the HDL and the cholesterol. We can also detect anomalies. So for example, if I spend, let's say, $1,000 every month on my credit card, but then one month I have a $4,000 charge, that's obviously an anomaly, and then it will be flagged. I can also use it to make recommendations. So we've all used Amazon, and every time we make a purchase, it always recommends something else that could go along with it. So for example, if I buy a pair of jeans, it may recommend a pair of shoes to go along with it, or a nice sweater. And then we have a time series sequential data and image classification, where we'll take an image and be able to classify it into one or more categories, or identify the object within that image. So these are the different types of predictions that we have. But then in order to be able to develop a model, it's basically a circular process, in the sense that, as you see at the top of the diagram, first and foremost, collect and load the data. Once we've collected the data, and in many cases we already have all that data within our organization in tables and archive databases, and it's just sitting there. So we can actually take that data and start to develop a model out of it. And to do that, essentially we would create a pipeline, and you'll notice that underneath the create pipeline, you'll see that there's an append method. So this method is basically what is used to create the pipeline in order to feed the machine learning model. And then you see the next step in the process is training the model using the fit method. And what the fit method does is it actually, like as the name suggests, it trains the model in the sense that it reads all the input or all the features, and then produces the labels or the output values. After we're done training it on a specific set of data, then we want to evaluate it and make sure that our test is successful. And so we do that using the evaluate method. And so this is all done programmatically, and we'll walk through it in just a little bit, but there's also a user interface for helping to facilitate this. Now, once I evaluate it, if I'm happy with it, then I can publish my model using the save method, as you see down at the bottom. If not, then the circular process continues again, where I load more data, create the pipeline, train it, and evaluate it again. So it's a constant circular process there, until I get to the point where I'm satisfied with the prediction results. Now I can publish this model to be used in other applications. And I do that using the save method, as you see at the lower part of the slide. Now, to use the model, I've already trained it, I evaluated it, I'm satisfied with it, I published it, and I can use it either internally with other applications and share it with my other developers, or depending on the scenario, I may want to publish it so that others can download it and be able to use it in a public type scenario. But in order to use the model, essentially I would use the load method that will take that model and load it, and then I can use the create prediction engine and the predict method to be able to feed it in a set of data and be able to get the predicted result out of it based on what I had trained it. Okay, everyone with me so far? Let me pause and see if there's any questions in chat, and it looks like we're good. I should also mention, feel free to jump in at any point with any questions. But if there's no questions, then we'll move on. So in order to do all this, there's a couple of prerequisites that I have to do. First of all, I would need Visual Studio, and I would need to install the desktop development environment. So as you see circled, not only do I select the .NET desktop development environment, but also within that, with a subset of that, I select the ML.NET model builder. And what this allows me to do is to be able to right-click on a project and be able to add a machine learning model directly into it, just like I would add a class or a config file or what have you. Now, there's three ways of creating the ML.NET or the machine learning model. I can use it, the UI, as you see in this slide here. I can also do it programmatically, which would involve using the Microsoft.ml NuGet package, or I can do it through the command line interface. So three separate ways of doing it. So let's jump into a demo. And what I have here is Visual Studio 2022. And all I did was I created a basic template for a console application. And I just created this just before the presentation. So as you can tell, it's empty, it's very basic. Now what I'm going to do is I'm going to right click on the project. And just like we saw in the previous slide, I'm going to select Add and select Machine Learning Model. And while that's loading, let me take a drink. And so I'm going to select the machine learning model from the list, and I'm going to leave the name default mlmodel1.mbconfig. Go ahead and select Add, and that'll take just a minute to load. Now, if you recall, we said there's three separate ways to put in the machine learning model within my application. And this is one of them using the user interface. And first it's asking me what type of scenario or prediction do I want to get? Do I want to do data classification, value prediction, image classification, etc.? And if you notice within each one, it specifies whether I'll be using the local CPU, or in the case of image classification and object detection, I can actually utilize Azure. And so in this case, I'm just going to do data classification. And then the next step is asking me for the training environment. Since it didn't offer Azure as an option, it's just letting me know that this is the CPU that I'll be using. And as you see at the bottom, Azure and GPU are currently not supported for this scenario, which is fine for my case. Now, next thing, like with all machine learning, I need to feed it data. It's asking, where's this data coming from? I can provide it in a file, or I can select it from SQL Server. So let me go ahead and choose a data source. We'll use SQL Server. And while that's retrieving the databases, it's a local database that I have set up. And let's speed this up and actually point to the server name, NIS 112. And then the database that I have in there is Iris SQL. Test my connection, everything's successful. Now, it's going to walk me through which table and which columns do I want to select. So the table is going to be Yelp labeled. And what this is, let me share with you the contents of that. Basically, it's a download of items from Yelp, and it's basically reviews. So as you see here, granted, this is not the exact table, but this is the file that was used to load the table. I have a comment or a sentiment on the left, and then I have a value indicating whether that comment is positive or negative. So 1 is positive, 0 is negative. So I have a bunch of comments, and then I label them either positive or negative. This way in the future, I can feed it in a comment at random, and then it can tell me whether that comment is positive or negative. And so that goes along the lines of data classification, the scenario that we selected. So now that I have the table selected, the column that I want to choose, that I want to, the label, that's the output. And in this case, it is the results. And at the bottom, you see a data preview snapshot where I have the column for the comment and then the column for the results. So I want to train it on the results, and then the comments are actually the features, the input. Once I set all that, now the next step is training it. How long do I want to train it for? And I'm going to go ahead and select 10 seconds for the sake of time, and I'll click Start Training. Immediately you see that I have a message that pops up and it says 10 seconds is not enough to train all this data. and it suggests doing it for longer. Would you like to continue anyways? I'm going to go ahead and say yes, because I want to show you the results of what's going to happen if I don't follow that recommendation. And after 10 seconds, you'll see that the best accuracy that it came up with is 49.95%. And as you see here, it says finalizing model. And once the model is finalized, then I'll be able to proceed on to the next step where I will be evaluating it. And we'll give it just a minute to finish finalizing it. There we go. All right, so I got training complete with a check mark. It's giving me statistics on the results of that training. Now my next step is to evaluate it. So if I give it a message that says, for example, looking forward to coming again. And let me go ahead and paste that in. So because the accuracy is 49.95%, it is still not sure whether this is a positive or a negative comment. So you see the results, I get 50% even split for the two. What if I try another comment and say, don't bother coming here? Again, it's a 50-50 split, it's not accurate. And that's because I bypassed the first step where I didn't give it enough time to train. And so let me go ahead and I can go back to the previous step. Now I can give it the adequate time for 60 seconds. And we'll go ahead and say train again. Now it's going to start chugging through. And as it's doing that, take a look at the output window on the bottom. What it's doing is essentially it's going through a variety of different algorithms on that data. And these algorithms are what are called trainers. So there's different trainers that it's going through. And again, for each one, you see the results and the accuracy. And it's showing the number of iterations that it's going through, meaning it's going through all the different trainers. And then once it's done going through that set of trainers, the cycle repeats again to refine the training results. And so we have about 20 seconds left. While we're waiting for that, let me check and see if we have any questions in chat. And still none. All right, even though it's not completed, you see that my results are upwards of 80%. So the accuracy increased drastically by giving it enough time to train. And then in addition, it went through 10 separate trainers where it cycled through and was able to train the model better. Now that it's fully trained and I spent the adequate amount of time on it, I can go on to the next step, and then I can give it a comment such as the same one that I gave it earlier. Don't bother coming here. Predict. And you see that it is 97% confident that it is a negative result. So now my accuracy improved drastically because I gave it adequate time to do the training. Let's go ahead and give it another example. Let's say looking forward to coming again. And we click predict. And that picked it up as a negative, which again will have to be more training. But let's give it another example. And again, 98% confident that this phrase that I entered in randomly is a positive phrase based on the 1,000 records that I trained it on. So now that I'm satisfied with the evaluation process, now I can go on to actually consuming that model or publishing it. And so within the UI, it's giving me a couple options. I can use the code snippet here to be able to utilize the console, or to be able to utilize the model that I created, or I can add it in as a project into the solution. I can add it in as another console application or as a web API project. Now, before I do any of that, I want to call your attention over to the Solution Explorer. So there's my solution called MLDB2. All that it has in it is the ML Model 1, which is the machine learning model that I created, and then the program CS like all console applications have. No other projects and no other files. Okay. Now I'm going to go ahead and select the console application, add it as a separate project into the solution. So I'm going to go ahead and click that. The default name is console app 1. We'll go ahead and accept that default name. Now, a couple things happened here. There is the ML model that I trained in my original project. Once I was satisfied with that, now it published it and it put it into another project that I can use. How did it publish it? Basically, as a .zip file. So there you see ML model 1.zip. And then there's my new console application. And then more importantly, when I look at the program.cs for that application, there I have some code that actually leverages that model. And so it leverages that model by essentially utilizing the ML model and instantiates that class. And if you notice at the very top of the file, it says that this was generated by the ML.NET model builder. Excuse me. And so in order to be able to use it to make a prediction, basically what it is, it's instantiating it, and then we're passing in a comment, and then we're making a call to the predict method using that sample data that was created in the first step, and then it displays the prediction results by calling the prediction result.prediction. So this is the property that we get back. The prediction result is the class where we pass it in the sample data to actually create the prediction. Okay, so if I'm satisfied with that, I will go ahead and make that my startup project and set that true, and then go ahead and start that. Now it's compiling, and I should get a console window up in just a second. Apparently everything runs slow in the morning, and it is morning time here, by the way. So anyhow, I passed in the comments, crust is not good, and it shows me the prediction results is 0, and now it says, and the process hit any key to finish. That, and we're done. Okay, so it's a very simplistic demo of right out of the box what I can do with machine learning. All I did was provided the data. I specified what I'm going to be using as the feature, and then what I want to use as the label, trained it for adequate amount of time. Key word here is adequate, and then was able to evaluate it, get the results that I wanted, and then published it into another application. Okay. Now, let me pause here and see if we have any questions. And still none. Okay. All right, so once we've done that, now we can actually move on to other ways of doing it. So if we go to another application that I created, this one is called housing data. Now, if you recall, we said that there's 3 ways that we can implement machine learning. So I can do it through the UI, which is what I did in the first example. Another method is by doing it programmatically. And that's using the Microsoft.ml NuGet package. So once I have that, basically I'm going to be utilizing these 2 namespaces. And what I'm doing here is I'm specifying the data structure, which is going to be called house data. And I kept it very simple for the sake of the demo. basically I envisioned that the price is directly proportional to the size, and so I only specify two properties, the size and the price. Now, of these, the prediction result that I'm after is essentially the price that I specified here. And I'm giving it a column name of score. And once I enter into the main method, again, this is also another console application. What I'm doing here, first and foremost, instantiate the ML context object. Once it's instantiated, now I have to give it some data. And so you see that I have within the demo, everything is commented as far as the various steps that I'll be doing. So the data is just basically a basic structure of house data that I defined up above, and I'm specifying the size. So 1,100 square feet will have a price of 120,000. A size of 1,900 square feet, a price of 230,000, etc. Now I'm only giving it four examples here, or four records rather. Obviously, when you're training it, more data equals better results. And so after I do that, if you recall from the circular diagram that we discussed earlier, that I want to be able to load the data. So let me pull that up real quick. And this is the slide that I was referring to. So we want to get the data, then we want to be able to create a pipeline, use the fit method to train it, and then use the evaluate method to evaluate it and see if it needs improving. And then when we're done, we're going to use the save method to save the model off. So once we get back into our application, first thing that I'm doing is I'm going to load the data, or set the data rather, to the house data, which is this object that I have here. Then the next step is I'm going to identify what's going to be used as my feature and what's going to be used as my my label, or the output result. And so here, feature will be the size, and then the price is what's going to be the label that I'm going to be using. That's the output result that I'm after. So I gave it the data, I identified what is a feature, what is a label. Now it's time to train it, and we do that using the fit method. So we pass in the training data that we identified in previous steps, and after we're done training it, then programmatically we're going to make a prediction, and that's going to be done using the create prediction engine. So we create the class, and then the method that actually does the prediction is the predict method, and for that we pass it in another size. Now if you notice, the size that I'm evaluating it on is 2,500 square feet, and it is not found in the data set here. It is, so I gave it a rough idea of the different pricing of the houses in the area based on square footage. And then I said, well, what if there was a home that was 2,500 square feet? How much would that go for? And so I'm evaluating it using that, and then it will actually produce the results in the last step here. So let's go ahead and run this application, and we'll put a breakpoint at the very top. All right, so now, again, we stop at the ML context. So once that's instantiated, then we're going to feed it data, and then we're going to load that data. We're going to identify our feature and our label, and then we're going to train it, and this should go by very quickly based on 4 records. Now we're going to evaluate it for a value that we don't have in our record set, make the prediction, and then display the results. And as you see here, and I'll put them side by side, it says the predicted price for size 2,500 square feet is 276,000. And so if we look at our data, we see that we have 1,900 square feet is 230,000. 2,800 square feet is 300,000. So a 2,500 square foot home lies right in between here at 276, which right off the bat sounds pretty accurate. And this is, again, using the linear regression type of model. And then if we expand it, now it's going to read line, where it's basically just waiting for input from the user. We'll go ahead and hit enter. Now I can further evaluate it even more. And go on to the next step. But more importantly, what I wanted to show you is now that I'm satisfied with the model, I can actually save it. And again, just like we saw in the previous slide, we save it using the save method. And this is going to publish it as a .zip file. And then we're essentially done. Now, where's the zip file located? If I go over into my folder structure for house prices and go over into my bin, debug, and let me share the folder structure with you. So this is where I have my solution. And if you notice that there's a model.zip that was at 7:36 a.m., which is my local time here. Now, what does that model look like? If I was to take it and unzip it, let me copy it off and go into another area. When I open up my model, it is not meant for me to unzip it and take a look at it. It is basically a lot of what appears to be arbitrary data, some transforms, some things that, again, I can just keep going down the rabbit hole, but things that don't make sense to me. However, I can take that zip, incorporate it into my solution, as we did in the previous projects. Let's pull up this one. In the previous demo that I did, or the first demo, you saw that I saved it off and it was a .zip file, and it just included that within the new project. Okay, so typically I don't have to unzip it or deal with it. I just take that zip file, copy it off into another project, reference that model, and then I'm off and running. Okay. Again, feel free to jump in with any questions at any point in time. Otherwise, we'll march forward. So we saw two demos where we were able to do it using the user interface as well as doing it programmatically. Now, the time to train. This is a general rule of thumb. It is not a hard and fast rule, meaning that more time that I give it and more data, the better output results will be. So if I'm dealing with a data set size of 0 to 10 megabytes, typically the average training time is 10 seconds. However, in some cases, it's going to require more. As you saw earlier, the more time I gave it to train, the better the accuracy was. Now, if I want to improve performance, there's a few things that I can do. Primarily, I need to give it more data. So the second example, I only used 4 records, and granted it was a small record set and it was able to derive the linear regression from that. But if I want to deal with actual data values, I need to give it many more records. And that's not really that big of a deal because many organizations already store all that data already in their databases. So to improve performance, first and foremost, more data. But not just more data, but rather clean, meaningful data. So we talked about the housing prices and the size of the home, but in reality, the price of the home is dependent on a lot of other factors. Obviously, first and foremost is location, then the size, the number of bedrooms, the amenities. Does it have a swimming pool, a large backyard? Is it overlooking a hill? All these things, they go into producing more meaningful data. It is not just square footage like I did in the demo. And data with context, that builds on what I was saying earlier, where we want to give it actual data within the context of within the context of how it's used. So again, with homes, It's not just the size, but rather how many bedrooms and what other amenities are involved. In addition, to better improve performance, I can utilize cross-validation, which is a model evaluation technique that splits the data into several partitions, and then it trains multiple algorithms on these partitions. So this can be effective on using smaller data sets. The other thing that I can do is utilize different algorithms. And if you saw earlier, when I was training my model in the first demo, when I gave it 60 seconds, it had ample time to go through various algorithms, and my accuracy went from 49% to 80% or higher. So where can this be used in real world scenarios? So we talked about the classification or categorization, where we can identify customer feedback as positive or negative, and this will help to automate things. So for example, if I'm feeding it in data that I'm getting from Yelp or from Twitter, and I need to identify any negative comments and be able to address them, I can use my application to capture any negative comments and then be able to send an email to the appropriate department or the appropriate people to be able to handle that. I can use regression as I did with the home pricing, as we had seen earlier, or anomaly detection to detect any fraudulent transactions. In addition, if I'm having a commerce website, I want to be able to make recommendations to my users. You purchase item A, and I need to recommend that item B will go along with it. I buy a pair of jeans, a nice pair of shoes would be a great accompaniment. I can use time series or sequential data where I can forecast product sales and identify highs and lows of my sales to better prepare my inventory for it. I can also use image classification, which is one of my other favorite features, and that utilizes Azure Cognitive Services. But I can use that to categorize an image. In some cases, in medical images, I can say this is a cancerous looking x-ray versus a non-cancerous looking x-ray. A lot of things you can do with it realistically within your business. So a couple of gotchas that I always like to mention. Pardon me. So 32-bit is supported on Windows, except if we're using TensorFlow or LGBM, or excuse me, Light GBM, and other Onyx-related functionality. If you get the error where Microsoft.ml currently supports 64-bit and 86 processor architectures, please ensure your application is targeting that. So to resolve that, essentially go into project settings, build, and then set the platform target to 64-bit. A third gotcha. If you notice, when in the first demo, we created the application, and let me jump to that real quick. So we started off with this ML demo DB2. We used the user interface to create the model and then publish the model into my new console application. But then you notice a message up on top that says, this project is targeting a version of .NET which is not installed. So for whatever reason, this ends up using a different version of .NET, but I can easily click the install button here to resolve that issue. Okay, so 3 gotchas that I wanted you to be aware of. Now, let me pause here and see if you have any questions. And if not, I have some questions for you. So, what are the 3 different ways that we can use to create a machine learning model? And I know it's either very early or very late, depending on which part of the world you're in, but there's 3 ways. Someone wanted to chime in with a comment? Maybe not. Okay. So 3 ways of creating it. We can use the user interface, we can use the command line interface, or we can do it programmatically as we had seen in the demos. When I take my data, I need to provide it features, which are, let's take the price of a home, the number of bedrooms, the size, the location. All these are features or input values, and then the price is my output value. And we call price, we refer to it as the label. That is the output value that we're after. And if we go back into our slides, so some references. If you look over on Microsoft Docs, They have some great how-to tutorials. In addition, as far as the terminology, with the different algorithms and the different models that can be developed, you can check out the deepai.org. They have a glossary of terms there. And then expanding on what we had talked about, improving machine learning performance. Again, Microsoft Docs did a great write-up on that. If you're interested in possibly evaluating and seeing if this is a fit, feel free to reach out to one of my peers at NIS Technologies. The website is nistechnologies.com, and simply send a question through consulting asking if we can do an evaluation to see if machine learning can be applicable in your organization. In addition, we also offer a variety of courses related to SQL Server as well as machine learning. And if you're interested, you can find me, any of my contacts, over on Linktree. But more specifically, my contact information, my email is snasser@nistechnologies.com. You can also find me on Twitter at Sam Nasr. And then my blog, where I post various technical events as well as technical and articles related to machine learning and AI. The link for that is samnasser.blogspot.com. And lastly, if we haven't connected on LinkedIn, I invite you to do so. And so with that, let me check and see if there's any questions. And still none. Okay. But you have my contact information. Just because the presentation's over doesn't mean the conversation stops here. Feel free to try it out. If you have any questions, reach out to me. I would be happy to help. And so with that, thanks again, and thanks to Ahsan for having me, and thank you for organizing it.
Thank you, Sam. Actually, the event is running almost 11 hours, so people are very much tired, I feel.
My pleasure. Always happy to help.
And actually, your session is nice, and the Bangladeshi community is actually in the learning phase of machine learning. So I'm sorry that this session audience cannot interact with you, but hopefully in next time it will be much more interactive.
No problem at all. My email is available. Always feel free to reach out to me afterwards.
I will also request to the audience that if you have any question in the next time, or if you in the time of working, please reach out to the Sam and he will help you. And there are many opportunities you can get consulting service also with from him. Thank It's a nice things. Hope you will enjoy that. Thank you very
Thank
much,
you,
Sam.
Ahsan.
Thank you very much for your time, and we are very much sorry that it's too early to attend for this event.
No problem at all. Very manageable.
Thank you very much. We are very much uh, happy to have you with us.
Thank you. Likewise.
Thank you very much. Hello, audience. So this is the last event, last session of our today's SQL Saturday of this 2020, and we are requesting you to join our next monthly event on 17th December. In third Saturday of each month, we are arranging a monthly meetup event, and renowned speaker are joining on this, taking different type of sessions on data platform and application development, AI and machine learning. So hope in the coming session you will enjoy. And if you have any question or any type of queries, you can directly contact with our honorable speakers. They will always ready to help you. Thank you very much. We are going to end the session. Thank you everyone for joining and enjoying today's SQL Saturday. Goodbye.
আসসালামু আলাইকুম ভাইয়া।
ওয়ালাইকুম আসসালাম। থ্যাংক ইউ ভেরি মাচ সবাইকে থাকার জন্য। ইনশাল্লাহ 17 ডিসেম্বর আমরা আবার নতুন একটা মিট আপ ইভেন্ট করব। সবাই আপনারা প্রেজেন্ট থাকবেন। থ্যাংক ইউ ভেরি মাচ এভরিওয়ান।
আসসালামু আলাইকুম।
ওয়ালাইকুম আসসালাম।
Thank you, Ahsan. Bye, everyone.
বাই এভরিওয়ান।